Good morning, calculus class, periods 2 and 3. This is Miss G, and it is Wednesday, April 1st. Ooh, it's April Fool's Day. Okay, well, we're going to start with a requested homework problem, and it's number 21. Okay, on page 336. So here we go. All right, we're integrating x over x squared plus 1 dx. We're doing a u du substitution, and our u is the denominator, x squared plus 1, because our du then becomes 2x dx. Looking back at the original problem, we have the x dx, there it is, but we picked up a 2 in our du that's not in the original problem. So we need to get rid of that 2 by multiplying by the reciprocal of 2, which is 1/2 in front of the integral. And now we're integrating 1 over u du. We bring down the 1/2. The integral of 1 over u du we learned yesterday was the natural log of the absolute value of u plus c. And then we can take out the u and put in the x's. So we have 1/2 natural log absolute value of x squared plus 1 plus c. But we don't need the absolute values. If you have them, that's fine. But we really can just put parentheses around them because x squared plus 1, no matter what x value you put in, is always positive. So I would accept this answer, but this is actually a little bit better without the absolute values. 1/2 ln of the quantity with parentheses, x squared plus 1 plus c. That's a good answer. But I noticed in the back of the book, they didn't put that answer. They used a log rule on the answer, and they used the rule where you can take the number in front of the log and put it back as an exponent, as if you were condensing the log. So the 1/2 ends up here, and we end up with ln of the quantity x squared plus 1 to the 1/2 plus c. And remember, the 1/2 power is the square root, so you could also write it as a natural log of the square root of x squared plus 1 plus c, which is what I think they did in the back of the book. But either this answer, or even this answer, or this answer, they're all good answers for me. Okay, that's the question we had to review. Let's see what we have next. We have, too much stuff we have. Okay. Let's take a look. We have one last kind of problem that I'm going to do in section 5.3. It's when you get a rational expression, that means you have a numerator denominator, and the denominator is a monomial, a single term. Then, before we integrate it, we're going to split it up. And I know you've split these up before, I think in the last chapter. So, it's a little bit of review and a little bit of our new material that we learned this chapter. So, here we go. To split this up, I hope you can follow my blue circles here. We're going to put 3x squared over x squared plus 2x over x squared minus 1 over x squared, and that looks like this. 3x squared over x squared, 2x over x squared, and 1 over x squared. Of course, we bring down our plus and our minus, our integral sign, and our dx. Then we're going to reduce this. So before we integrate, so 3x squared over x squared is 3. Plus 2x over x squared is 2 over x, minus 1 over x squared dx. Okay, now I'm going to rewrite it just a little so it's easier to integrate. So the 3 stays the same. The 2 over x is the same as 2 times 1 over x. And then we could write 1 over x squared as x to the negative 2 power. So there's our rewrite. Now, we can split it up into 3 separate integrals. I'm going to do it here, but actually you can just integrate the 3 and then the 2 times 1 over x and then the negative x to the negative 2. And you could skip this step, but I wanted to show you this step so you can see why we get to where we do. So this splits into the integral of 3 dx plus, I can take the coefficient 2, put it in front of its integral of 1 over x dx, minus the integral of x to the negative 2 dx. So there are our 3 integrals. And so we're going to integrate them one at a time. So the integral of 3 with respect to x is 3x. 2 is a coefficient, bring it down, and the integral of 1 over x dx is what we learned in this chapter, is the natural log of the absolute value of x. minus, and then integrating x to the negative 2 is what we learned in previous chapters where we add 1 to the negative 2 to the exponent. We get negative 1. We divide the coefficient, which is 1, by our new exponent, which is negative 1. So we have 1 divided by negative 1, and we bring down our negative. And we put in our plus c. Okay? And then we simplify. We get 3x plus 2 ln absolute value of x minus the negative becomes plus x to the negative 1 plus c. And I think I wrote it as 3x plus 2 ln x plus 1 over x plus c. And that's how they would write it probably in the back of the book. You could take this 2 in front of the ln and put it on the x and make this the ln of x squared, and then you wouldn't need the absolute values because x squared is always positive, but this is fine. I hope you followed that. I'm going to do one more. Okay. Same kind of problem. We have a polynomial in the numerator and a monomial in the denominator of our rational expression. So we're going to split it up. I saved a few steps on this one. I didn't make it quite as long as doing the other one. So I immediately divided 2x cubed over x squared minus 6x squared over x squared minus 5x over x squared dx. And there's our integral. Then we reduce it. We get 2x. We get minus 6, and here an x cancels an x squared, so we get minus 5 over x dx. So now what are we looking at? Looking at the 2x minus 6 minus, but then I pulled the 5 out so that you could see that this was 5 times 1 over x dx. Now I'm going to integrate. And I could split it into the 3 integrals, but I think you can just integrate each one right now. So the integral of 2x is x squared. That's our add 1 to the exponent. We would get 2, divide 2 by 2, we get 1. There's x squared. Minus the integral of 6 with respect to x is 6x, so minus 6x. And then the 5 is a coefficient here, so minus 5 times the integral of 1 over x, which is the natural log of the absolute value of x plus c. So we get x squared minus 6x minus 5 ln absolute value of x plus c. And that's a good answer. Okay, I think that's it. All right, so I only have 2 problems today, section 5.3, page 336, numbers 31 and 33, and they're like these 2 problems. All right, and I hope you have a great day. Take care.